of 2025. And Dr. Yunxing Lu is currently working as a postdoc fellow at the University of Pittsburgh. And he obtained his Ph.D. degree from the Department of Civil and Environment Engineering at the University of Pittsburgh. And he has a very strong expertise in experimental rock mechanics and geomechanics, as well as AI-driven related research. And today, I'm very happy to have Dr. Yunxing Lu to give his most recent exciting research. Thanks, Yunxing, and it's your turn.
Thank you, Yao. Thank you very much for this nice introduction. Hi, everyone. My name is Yunxing. You can also call me Aaron. That's my Starbucks name. And I'm a postdoc researcher from University of Pittsburgh. And the talk I'm going to talk about today is how to use the AI-driven approach to access the oil spills impact. Specifically, I will use the techniques of the data augmentation and fine-tuning large language model and use the NOAA data in Gulf of Mexico as an example. So before my presentation, I would like to take this chances briefly introduce myself and my background. So I got my master from A&M in geomechanics before I moved to Pittsburgh. And since then, I've been fortunate to work with my advisor, Professor Andy Bonger, and I'm very grateful that he has provided me a lot of help, guidance, and the resources, and most importantly, the freedom to explore things that I'm interested in. And I have enjoyed staying here and working with him. And of course, with many of my collaborators from the many institutions which I have listed here. So as you can probably see from my last slides that I've been received my training as a geomechanics engineer. So which lead me to two major applications, which are the enhanced geothermal system and the plug and abandonment. We also call it the P&A. So in the EGS field, during my time at A&M and my current postdoc, and I have been particularly interested in exploring two areas. The first is how to enhance understanding of the THM coupling effects and how to apply them to better engineer and fracture and control the fractures in the EGS system. And second is how to improve the industrial stress analysis for the complex fracture networks in the geothermal system. So in the P&A application, which was my focus during my PhD time, so my research centers around the three main directions. The first is how to advance geomaterials development for the extreme conditions. So for here, extreme conditions mainly refers to the high temperature, high pressure conditions. And second one is how to improve the P&A operations by refining the current codes and the standards through the thermal mechanical analysis. So the last is how to enhance the P&A operations by improving the environmental regulatory compliance and economic efficiency. Actually, the topic that I'm going to present today, accessing the oil spills using AI-driven approach, actually falls into the last category. So before we dive into this specific topic, I'm going to spend about 5 to 10 minutes to give you a very high-level overview of the work that I have done across those four main areas that I just mentioned. And for each of area, I will use one example as an illustration. And however, today's topic is about the AI application to the oil spills data. So how can geomechanics and the AI come together to bring us a brighter future? I will be very honest with you. I only have a very vague ideas at this point, but I believe after today's presentation, we will have a better and clear picture, or at least spark a very meaningful discussions, I hope. So the first one that I'm going to show you here is how to improve the industrial stress analysis for the complex fracture networks. I think one of the main pain points for estimating the industrial stress in EGS is due to the limitation of the simplified model used for the traditional reservoir analysis and the data interpretation. So because of the high temperature, the EGS wellbone cooling down caused by the injection and the circulation will always induce the changes in the thermal stress field and create a more complex fracture patterns. So those conditions can largely influence the wellbone pressure history, which will also cause problems for the interpretation of the initial stress estimation methods. So through our experiment during the water injection into the hot specimen process, we have found that a very large thermal gradients can be caused during this cooling period. As you can see in the top figure, where the thermal gradients were measured by the embedded thermocouples inside the concrete block, it can induce a very large bowing fractures only by the thermal shock under the unconfined experiment. So it leads us to think, how should we have a better understanding of this thermal hydromechanical process during the EGS well stimulation phase, and how should we better control the thermal effect to help us to create a more ideal fractures? So guided by this concept, we conduct a large number of the true structural experiments which are simulating the Utah forge conditions, which we have considered several parameters, including the thermal effects, wellbore, well deviation angles, material anisotropy, and the operational parameters such as flow rates, fluid viscosity, and to collect the relationship between the wellbone pressure and the fracture trajectories. So if we rework those data into this Sankey plot, we have found that the two parameters are actually dominant here, which are the different interior stress combinations and the thermal effects. So how should we see this figure or Sankey plot? Actually, it should be viewed from the both sides towards the center. So the left and the right side are representing two different categories, which are the vertical wells and horizontal wells. For each categories, under the same interior stress conditions, we conduct two comparative experiments. One is with the thermal effects, another one is without the thermal effects. So the centers here shows three categories of fracture patterns that we collect, which are longitudinal, transverse, and mixed. So mixed here means both longitudinal and transverse fracture are presenting. So through the extensive experiments, we initially found that under the same experimental conditions, in the absence of the thermal effects, if the interior stress condition favor the generation of the longitudinal fractures, the fracture pattern will shift to the transverse when the thermal effects is applied. Through many of the experiments, we have demonstrated that have a better understanding of the role of the thermal effects in the hydraulic fracturing phase in EGS could potentially enable a better control or the generation of the ideal fracture patterns under the unfavorable conditions. So moving to the PNA applications, as many of you are probably wondering, so what is the PNA here? So it actually means permanently plug and abandon the well. As we all know, the life of a well usually have 4 periods, starting from the drilling, completion, and the production. However, when the production is lower than the economy limit, that's when the PNA starts. So it is happening at the end of a well life cycle. So the common practice in PNA involves using multiple barriers, and which most of them are made of cement. So people outside the PNA field always have this misconception that the PNA is very simple, assuming it's just a matter of dumping cement into the well and finger crossed, hoping for the best. But in reality, I think it's far more complex. I think the primary function of those barriers is to ensure the zonal isolation and prevent the leakage. A successful PNA job actually requires careful considerations and design and the ability to overcome those challenges. So I think one of the main challenges is coming from the extreme conditions of the PNA. So in the context of PNA, the extreme conditions primarily refers to the 4 factors, which I list here, which are high temperature, high pressure, acidic fluid attack, and drilling mud contaminations. That's one of the most critical factors for a successful PNA job is that the materials that we use can actually overcome those extreme conditions and endure over the geological time frame. So therefore, my first research interest and the directions in the PNA is to develop the geomaterials that can better withstand the extreme conditions over such an extended period. So we have successfully discovered and developed several options and candidates for such advanced geomaterials. So one of them is we call the geologically activated cement, we also call it GAC. So which is designed for the overcoming the acidic attack and high temperature, high pressure conditions. As I mentioned earlier, under the extreme conditions, CO2 attack is a significant factor. I think this is because for the common used well-sealing materials are the ordinary cement, which can survive in the basic environments, but it will be very highly unstable in the acidic conditions. So let alone over a geological time frame. So therefore, we proposed and developed a very innovative approach. So we're using the reaction between the magnesium silicate and the carbon dioxide to produce a magnesium carbonate binder. We're using olivine sand particles and allow it to react with the carbon dioxide under the high temperature, high pressure conditions to create a binder that serves the well-sealing material. So this is not only turns the waste into the value, but also transform the carbon dioxide from the threatening factor into one of the raw materials for production. And moreover, if this raw material actually is specifically for the CO2 is actually continuously available within the reservoir. So even if a fracture occurs in the GAC at some stage of the PNA, the newly formed binder will continuously fill this new formed fractures and achieving effect of the self-healing. So therefore making the entire sealing process more resilient. And my second research interest in PNA application is to improve the design on the operation of PNA materials and procedures. I think currently the most prevailing ideologies of the plugin materials is that the lower permeability is better. I think, well, this may seem intuitive and reasonable at the first glance, but I think it deserves reconsiderations in the specific context of PNA, especially under the high temperature and high pressure conditions. I think no matter what kind of materials, plugin materials we're using, it will be ultimately a porous material. So in the extremely cases, zero permeability actually does not equal to the zero porosity. So that means in the high temperature, high pressure environments, inducing pore pressure changes in the low permeability cement can become problematic. I think because such a material is not able to drain the excess pore pressure quickly compared to the rate where and when it's built due to the thermal changes. And it will lead to the generations of the internal tensile stress and an increased risk of the damage. So by utilizing the dimensional and the pairwise variable analysis through the Monte Carlo sampling, we're proposing a concept of the permeability penalty. And I think this introduced a new wellbore cement design approach that focuses on achieving the lowest safe permeability, which is minimizing the failure risk from the pore pressure buildup, rather than simply targeting for the lowest permeability possible. The last point here for my PNA application is actually for the compliance efficiency and economy efficiency. So why those two are important, I think the following 4 points could provide a really strong support and explanations. So let's look at the first point together. So by the time of last summer, there's more than 200,000 documented wells in US are waiting for the plug abandonment. And averagely, each of them will cost around $10,000. And their spatial distribution is widespread within the US. And I think more importantly, there is an estimation that there's a number between 300,000 to 800,000 of undocumented wells in US is waiting for the PNA. So if you do a simple math, so this will be the huge amount of money. If we zoom into the Gulf of Mexico, there is a totally around, by the 2021, there is totally around 50,000 wells in here, and half of them are waiting for the plug abandonment. And according to the statistics model developed by the NOAA industry, it will probably take us 15 rigs and 50 years to finish those PNA job only for the in the deep water zone, which will cost over $300 million. Okay, if we are going to spend that amount of money and we want to know is accurate, is the current P&A job successfully preventing the oil leakage, given the current P&A standard and practice? And more importantly, what's the current status of the oil leaks and how do they impact our environment? So interestingly, we have found a public oil spill datasets offered by the NOAA, which provide very valuable insights for our study and questions. So NOAA is one of the key organizations involved with tracking and studying the oil spills in the US water system and provides publicly accessible data sets for the oil spills records, I think dating back to 1967. And their data is public accessible through the link here. So firstly, we can take an overlook of the overall structure of the NOAA oil spill data sets. So for each of the entry are follow a specific format and including several key informations here. For example, the Earth's coordinates and the tags and the release volume and the descriptions of each incident. However, it's important to note that while only the date and the location data are mandatory field here, the other details, for example, the oil release volume or specific incident tags are incomplete. Actually, they are missing in a lot of cases. But at least with those two information, date and the location data, we can use those two information to have an overview of the data. I think the first figure shows how many spills each state has, and the second is what the temporal and the spatial patterns that we have. So we can see that it's clear that those oil spills are not randomly distributed. They have distinct patterns in both time and the location. So for the location-wise, we can definitely see that the Gulf of Mexico is a hotspot. It makes sense because that's where the most activities happens. On the west coast here, California and Washington State follows close behind. Well, the Northeastern doesn't have many incidents as the first two region, but it is still part of the picture. Oops. So after getting the overview of the oil spill data, I think the next questions would be, what are the reasons to cause those leaks? So if we look back to the original data sets, one quick way to find the leak reasons is to check these tag columns. But unfortunately, like I mentioned before, there are a lot of information missing here. So our preliminary and initial observation reveals a very concerning statistic. Is over 85% of the tracking tags are missing, and we have no clue why they're missing. And second, the records are all over the place. As you can see here, most people are freestyling using the words for the tag. It's very disorganized and making a very significantly challenge for doing research in this field. I think one of the primary factors contributing to this issue is the lacking of the standardized national protocols for reporting oil spills. I think there is a gap in our system that become evident through the years of research. So taking myself as an example, if I spot an oil spills, I have no idea how to report these oil spills, even though I have been doing research in this field for many years. So I took this picture during my summer travel in Alaska. So actually, this is my first time literally see a clear documentation in public to show people how to properly report the oil spills events. However, it's also lead us to think a question, what if oil spills happen in Pennsylvania or in Oklahoma? So who should be the point of contact for reporting? So nonetheless, if we really want to know and understand the causes of those oil spills, one way would be to read through the incident descriptions here. But the data set contains over 5,000 entries, and as you can see here, each description is filled with abbreviations and technical jargon, making them super difficult to read and understand. And honestly, I think no one would spend that much of time reading through all of them. We once hired an undergraduate student to help us label 300 entries, and she told me that Yunxing is very painful to read those. So here are the situation. So we have more than 5,000 entries of data that need to be analyzed, and each of them is difficult and boring to read. So what should we do? Maybe we can use some AI technologies to help us to read those data. One way to do that, to do this, is we can call OpenAI's API 5,000 times and let ChatGPT give us the answer. However, I think there's two major issues with this approach. First, it can be very expensive. After all, OpenAI's API is not cheap. And more importantly, ChatGPT as a large language model was not originally trained to analyze this NOAA oil spills data, especially when the description is full of abbreviations and jargon. And at least for me, when I using ChatGPT, it's super powerful. However, I need to be super cautious because devils are in the details. I know at some places AI will start to hallucinate and will confidently give you the inaccurate response. So given the abundance of the abbreviations and the technical jargon in those descriptions, the ChatGPT is prone to hallucinate and give you the inaccurate answer. So it's not a very reliable way to do this. So on the top of that, you need to carefully craft your prompts to ensure ChatGPT follows your instruction accurately. So that is to say, can we train an AI that is specifically designed for the NOAA oil spills data for better accuracy and, of course, for free? So the answer is yes. But before that, we need the natural language processing techniques to pre-process those data, which means we have to roll up our sleeves to clean up those description data. So a big part of that is coming up with a set of sensible tags to make future research easier. So we pre-process the text from the description column and generate those word clouds. So maybe you are still looking for the words, for example, well-born platform, but as you can see, actually the first thing jump out of at us is the word vessel. And if we dig a little deeper, and you will find the terms related to the marine and waterway transport, such like barge, tank, and as well as all you spill specific terms like gallon and diesel. So if we rework the word cloud and pull out the top 30 words by frequency, you will see something interesting. Actually, the well and the platform are actually way down the list. And the word taking the center stage are mostly about the marine and water transport, such as a vessel, barge, cargo, and even facilities. So by observing those, we are defining those oil spills into the 9 new categories. The first categories, the first 4 categories are relating to the water transport. They are passenger transport vessel, cargo, and petroleum transport and non-transport vessels. So the next 3 categories are relating to the infrastructures, the pipeline, platform, wells, and facilities. The other categories is relating to natural disasters such as earthquake and the hurricane. The last one is labeled as unknown since we really don't know the exact reason to cause those oil spills. So the current situation is that, like I mentioned, we hired undergrad students and she helped us manually label those 300 data, and we will treat this data as a gold label data. And if we throw those 300 data directly into AI, for example, Tiny Llama and BERT, and the testing results is not good, only with 30 to 60% of the prediction accuracy. So right now you're probably wondering, hold on a second. So what is Llama and what is BERT? So I would like to take this chance to make some of the AI terminologies more clear. I don't want to dive too much details here today, but I do want to mention that a lot of AI we're talking about today is building up on the transformer neural network. For this type of neural network, it has 3 architectures, which are decoder only, encoder and decoder combined. For ChatGPT, it's actually standing for the generative pre-trained transformer. It's building upon the decoder-only architectures. And this is actually my favorite tree recently. Since we have 3 architectures, each architecture has their own product. So here, the more greenish branch is the decoder only, and the yellowish branch is decoder only, and the more bluish branch is encoder and the decoder combined architecture. So you can see the GPT family is on the yellow branch. And since it's not open source, it will be difficult for us to fine-tune ChatGPT. So we're using Llama to fine-tune with, which is also decoder-only architecture. For the encoder family, we're going to use a BERT. So the Llama we're using here has 1.1 billion parameters compared to the ChatGPT-4, which is claimed to have almost 2 trillion parameters. So we will call this 1.1 billion parameters Llama as a tiny Llama. And the BERT has 110 million parameters. And the GPU we're using to fine-tuning the large language model has 80 gigabytes. So as we all know, training a reliable AI is actually need a large amount of high quality labeled data. However, this seems to contrary what we proposed originally. The reason why we're at this page here is we simply don't want to read those data. So then the issues become how to solve the data scarcity issue when labeled data is too expensive or too limited. So to solve this data scarcity issue, we are proposing the AI-driven augmentation techniques. For the data augmentations, we have 2 methods for this. The first one is prompt-based large language model. The second one is we can train a generative adversarial networks. So for today, we will just focusing on the first method here. So to perform the prompt-based large language model data augmentations, the first step would be defining the critical attributes and the important features for each categories. For example, why certain labels are applying, and what are the key characters that distinguish one category from another. So the second step would be transfer those knowledge and rules to AI through the prompts. So here the screenshot shows a part of our code in our system. We can see that for each generated case, we're inputting the element types, key elements, and the vessel types into those prompts to capture the domain knowledge and the category features. And the third step will leveraging the large language model's few-shot prompt ability to inject the real cases from each category into the prompts. So this really helps us to capture the unique features of each categories, making the generated example as realistic as possible. So by using these carefully crafted prompts, we generate another additional 1,500 examples as a synthetic data, and then we can use those synthetic data to fine-tune our tiny llama. So at this moment, you are probably asking, okay, so what is the fine-tuning mean here? So for ChatGPT that everyone is using right now is called pre-trained model. So all those pre-trained models are trained on the whole internet data, which contains a wide range of information. I think the advantage for that is they have very broad knowledge, but the downside is that they do not have the focus and the precision when it comes to a specific area and often hallucinate. A good example would be if you ask ChatGPT, okay, what is a Christmas tree? It will more than likely give you the answer of, okay, it is a decoration tree during the holiday season in Christmas. However, it's not the answer that we use in our daily life in the oil and gas industry. So if you want this answer, you have to prompt more or give the large language model more proper context. So the fine-tuning here means we're going to feed in a lot of oil and gas information into the pre-trained model. So the last few layers of the pre-trained model, a last few layers of the parameters inside the pre-trained model will be adjusted. So next time when you fine-tune the large language model, when you use the fine-tune, ask a fine-tune the model, you don't have to ask specifically what does the Christmas tree mean in oil and gas industry? It will automatically give you the answer. So far we have used large language model prompt-based data augmentations techniques to generate the synthetic data. And we use those data to fine-tune the 2 open source large language model, Tiny Llama and BERT. We named them as Tiny Llama oil spills and BERT oil spills, which is specifically designed for the NOAA oil spills data. And we have tested those fine-tuned model with a prediction accuracy of 95%, which is outperformance the ChatGPT-4 with accuracy of 60 to 70%. So this is actually fulfilled our goal over the past 2 years is building more trustworthy and reliable AI for plug and abandonment. So, and now you are probably asking the question, okay, how can you ensure the synthetic data and the data augmentation is accurate and reliable? Well, we have several methods here. The first way is we have a statistical analysis tools, and we also have the semantic analysis tools. However, I think the more direct and efficient approach is to annotate another 50 real raw data points on the top of previous 300 data points. So it shows that when we use the trained model to make predictions, it is still achieved 95% of accuracy. So this is a very strong evidence that our approach works, as the model has never seen those 50 data points during the training. So this demonstrates that using synthetic data to train the model for the oil spills is actually a very effective strategy. And right now, we have the trained model that we like and satisfied, and we can use those models to relabel and reanalyze those oil spills events in Gulf of Mexico from the NOAA data sets. And here are the interesting facts that we have found. So firstly, the most common categories among those events is actually labeled as unknown, which is a little surprising for me. And the second most frequent causes is facilities. From third spot all the way to the second to the last, most incidents are the water transport vessels. And most interestingly, the spills from platform and wells leakage only account for only 17 instances. And of course, this number could be higher because we have more than 300 spills categorized as unknown, and some of them are more than likely coming from the platforms and well. But so far, we're only talking about the number of incidents. So how about the total volume of the oil spills in each categories? So based on the current data, we can see that although the platforms and the wells category has the smallest incident number, but it actually counts for the highest volume of spills. So I think this tells us when something going wrong here, it's a really big deal. And what's really interesting here is that if you combine the cargo and the petroleum transport, and their total oil spill volume actually surpass the platform and wells. So on the flip side, the facilities and pipelines has lower oil spill volumes. I think probably they have a better monitoring system, making it easier to detect problems and can fix them quickly. And in the Gulf of Mexico, we also mapped the incidence of each categories for two primary reasons. The first is that we want to identify the spatial distribution pattern to see the hotspot area for each of the categories. And second, we want to know where the unknown category incidents are concentrated. This is also involving some of the temporal spatial statistical analysis. This is also one of our currently ongoing work. So far, we have used AI-driven techniques to generate the reliable and accurate synthetic data, which helped us to solve the data scarcity issue. And with those synthetic data, we have successfully fine-tuned 2 large language models with a prediction accuracy of 95%. And with the fine-tuned model, large language models, we have a revisit and relabeled the NOAA data with the categories that we defined, and they have a very, very interesting findings. And more importantly, this fine-tuned model can not only apply to the text, but also for the well maps and historical well records, and even for the handwriting documents. So the above work really help us fulfill our goal in the last 2 years, which is building a more trustworthy and reliable AI for plug and abandonment. So to build a more trustworthy and reliable AI, there are actually 2 main approaches. The first one, which we already discussed, is fine-tuning. The second one is called retrieval augmented generation, or RAG. It's a very popular framework today. So on the top of the RAG, we incorporate the knowledge graph techniques, resulting in what we call knowledge graph RAG. So we're building this framework is mainly to overcome the AI hallucination issues, which we already filed the IP protections. So the AI hallucinations from the large language model are actually coming from the two primary resources. The first, the large language model itself is actually a massive statistical model, and it's prone to generate randomness. So by integrating this knowledge graph, we're aiming to guide the large language model from randomness towards more deterministic. The second source of the hallucinations actually coming from the token limitations or context windows of large language models. The token of the token limitation of the large language model is much more like a human brain. So the current model, like ChatGPT-4, has a token limits about 112,000. It's roughly equivalent to the length of 20 journal papers. That means if you input more than 20 journal papers at once, the large language models will almost certainly hallucinate. It's just simply because it cannot remember such long context. So by having this knowledge graph rack, we can actually have many meaningful applications. So one of them is we have built a chatbot that is specifically designed for the plug embedment. So what does it mean by specifically designed for the plug embedment? So it's not like ChatGPT, when you ask questions, it will search the whole internet data for you. We actually build a database for the P&A chatbot. So the database we have are primarily have three components, which are the federal local codes, regulations, and laws, and the plugin cases studies, and also the research books and papers. So for this chatbot, it has two important features to prevent the AI hallucinations. The first one is it's perfectly referenced. For every answer it generates, it will give you the pinpoint reference information precise to the page number. And if you have concerts of the output, you can easily trace those information. And secondly, unlike the ChatGPT, will confidently give you something that it doesn't know. So when the search topic is falling outside the database that we built, the P&A chatbot will honestly tell you, sorry, I don't know the answer. So let's demo how P&A chatbot will work. So this is actually a video record demo that we built. So for this P&A chatbot, we can basically ask anything about the P&A here. So we can start off from a very basic question, such as what are the minimum requirements of the plug length of the P&A? So once you hit the submit button and when the answer is generated here, the answer is primarily consists of three parts. So the first part, as you can see, in response to your question, it will return the most relevant laws and regulations involved and provide you with the process reference information so you can easily trace back. So for here, it will give you the codes and the section numbers. Then the P&A chatbot will select the most relevant law and summarize its content for you. As you can see, it always perfectly referencing the section and the code number for every answer it generates. And I think one of the most important features for this product is actually it can remind you the facts or the issues that you may have overlooked or is unaware of. And all here still is perfectly referenced. So if we, you can see here is perfect reference. So if we move to the research side, it will generate the answer based on the textbook regarding to your questions. So this will also give you the process reference information. So let's check the accuracy together. So from the results generated from the P&A chatbot, we can turn to the page of 192 of the book to verify the accuracy of the information it has provided. So on the right side screen is a screenshot of the page 192 from the book, where we will find the information given by the P&A chatbot is completely accurate. So currently, we're working with and collaborating with the Pennsylvania Department of Environmental Protection to enhance the P&A efficiencies through the AI-driven decision-making and education. And also, we're collaborating with the physicians from UPMC to improve the physician-patient communications by using AI. So come back to the question about the geomechanics and AI. I have some ideas and would like to implement in the near future. For example, we have demonstrated that by using the large language model prompt-based data augmentation can be a very effective way to generate the synthetic data. So those synthetic data is proved to be actually reliable and very useful. So can we implement this method to another data scarcity field, such as the geomechanics experiment data? So we can actually integrate the large language model, physical-based modeling, and the limited experiment data measurements to generate the synthetic data to enable a more robust learning despite the limited real data. Another direction would be, as we all know, the THM couplings are complex and strictly physical constrained system where it's governed by the series of constitutive equations. So can we develop a multi-AI system, multi-AI agent system? So each AI agent is controlling a series of operational parameters, and they're collaborating with each other within a shared environment modeled by the numerical simulators that can capture, for example, the heat transfer, the fluid flow. So this maybe will offer a scalable and physical constant solution for the multi-physics optimization challenges. So my final point is that as we are seeing right now, AI is transforming and reshaping every industry. And I do believe that have a deeper understanding of how AI works will ultimately benefit the geomechanics. Even though some of the paths forward are not entirely clear, I think that's the spirit and the beauty of the research. We need the courage and at the same time the wisdom to explore the unknown. So thank you very much for your time, and I will be happy to answer any questions. Hello? Can everyone hear me okay?
Yeah, I can hear you. I'll ask
Yes,
a question if no one else has one. I was just wondering if you could say more about the data augmentation part. I didn't quite follow that part, but overall that was fantastic presentation, really impressive work you guys are doing.
Thank you. So which part are you? I'm sorry, maybe I went too fast. So yeah, so basically we have 3 steps. So data augmentation is we hired undergraduate student help help us. Let me put. Sorry, I have 3 monitors here. It just gave me a hard time to see. So we hired an undergraduate student to help us label 300 data. So we will treat this as ground truth data, and then we for each of the data, so we define a new 9 new categories, and for each of the categories, we are extracting the key attributes and important features of each categories, and then we are creating automation tools in Python. So when we generate this synthetic data, we're importing those features into the prompts and let the large language model and we also injected real cases for each of the categories to a large language model mimic those data and generate the synthetic data. A more appropriate example is, for example, if I'm going to, like, if I had a chance to access to your email, like for example, if you give me 500 of your email, and I can analyze several attributes of your email, for example, your vocabulary choices, your like sentence lengths, and your grammar choice, and I can use those several parameters and tell large language model here is the writing habits of Jeff, and here are several examples. Please generate more emails like sounds like Jeff. So that's how we generate the synthetic data here.
Okay, so it's and that was the part I didn't get. So I thought you were just sort of fine tuning on the 300 labeled documents, but you actually created entirely new synthetic documents.
Exactly.
Okay, all right.
Yeah.
That's
so the
thanks. Yeah, that's cool.
Yeah, I'm sorry. So the reason why is, like, if you are going to fine tune your large language model, you need a huge amount of high quality data. 300 is obviously not enough. So That's the reason why I come up with the idea. Okay, can we generate synthetic data for fine-tune the large language model?
Okay, cool. So roughly how many documents did you fine tune with in the end?
2000. So
Okay.
like I found the two, like I first try, I generate another 300 and generate 600. And I found at the level of 2000, it achieved good accuracy. So because another reason is I'm using a very small large language model, is 1.1 billion parameters. So I think that's the reason why we don't need that huge amount of label data.
Sure. Okay. And then you implemented the knowledge graph reg using the fine-tuned model. And okay, cool.
Yeah.
All right. Thanks for answering my question. That was great.
Thank you.
Hi, Yunxing.
Hi, wait.
Yeah, great work. Very meaningful work and
Thank you.
very nice presentation. Thank you. I really enjoyed it. So my question is really about your vision in your future about like
Okay.
THM modeling. So how do you picture the role of large language model in the THM analysis or THM modeling? Like we used traditional machine learning approaches to build, let's say, surrogate models to predict THM modeling results. But how would you see the role of ChatGPT or the role of large language model in this?
I'll be totally honest with you. This may sound like a crazy idea, but this might just my idea. I haven't got a chance to implement those, but I have a very big idea right now, and I haven't implemented it yet. So I cannot answer your question right now. I'm sorry about that. Yeah, so that's the reason why I'm like want to spark a meaningful discussion here is how can we use AI to improve the geomechanics framework. So, but that's a great question.
No problem. We can talk at a different time.
Sure.
And also for when you train your large language model, what is your metric to evaluate its accuracy?
Oh, here. So that's a great question. So like the most efficient and the simple way is because I explained to Jeff, we label 300 data, we generate another 2000 synthetic data, and we use those data to fine-tune large language model. And once we fine-tune with, so for fine-tune large language model, of course, I split the data sets into testing and training data. And on top of that, I manually labeled another 50 data, and those data so large language model is never seeing those 50 data during the training. So I use those data to, fine-tune a large language model to make prediction on those 50 data and to check the accuracy of the results.
I see. Thank you.
Mm-hmm. Okay, any more questions?
Hi, Yunxing. Very, very great presentation.
Thank you.
Very interesting. And my question is actually a follow-up question for Wei's question. Yeah. So my question is do you have the experience to apply the AI-driven models, the large language models, to the discontinuity problems? I think for the
Unfortunately, no.
geomechanics, yeah, I think for the geomechanics, compilation with AI is the challenge.
Yeah, I
Maybe
agree.
the more challenge were on the discontinued problems, with the factors.
Yeah, I totally agree.
So do you have some comments on it or have some
I
experience?
don't have any comments on that. It's just like I stepped into this field like in this AI field 2 years ago. As you can see, my background is geomechanics engineer, and I stepped into this AI field 2 years ago, and take a different route. And right now, I'm trying to merge those two routes to see if we can marry the AI with geomechanics. What's the results it will be?
Yeah, I think that would be a interesting way and a significant way to consider in your future plan. And also, my question is also like for such method, AI method you mentioned, is there a minimal requirement for the data amount?
That depends on, I think that's a great question. That depends on the model, the open source model, the parameters you will choose. Like for example, for this 1.1 billion parameter model I'm using, I think a couple thousand will be enough for fine tune. But if you are going to use a larger model, I think it will require more data for fine tune with.
Okay, so you mean the data amount required for the accuracy also related to the different models you
Yeah, from
apply?
my understanding, yes.
Okay, that's interesting. Okay, thank you. So is there any other questions from the audience? And if you like, you can also type in the chat. Yeah. Okay. Anyway, our seminars, existing seminars will be uploaded to our ARMA Future Leader YouTube channel. And if you have interest and would like to see the past seminar you missed, you can follow up our YouTube channel. It will be updated. And also you can find our past seminar on the ARMA Future Leader website. It will also has a link directly to the recording of the past seminars. And for the next half of this year, we will continue host and hold the ARMA Future Leader Seminar. And I'm very happy to introduce that Yunxing will become the co-organizer for the second half of the year. Thank you.
Thank you.
Thank you. Thanks.